Am I on? Oh, brilliant, thanks. So firstly, I'd like to say thank you, obviously, to Sonic Axe Festival for hosting this event. I'm just going to start with a brief outline explaining the project Signal, which we presented on the 1st of February this year at CTM Festival in Berlin. And it was a part of a almost 2-year production process in the end, which manifested in a real-time radio-based broadcast that integrated ionospheric propagation. To start with the origins of kind of our research, ultimately, it probably started about 10 years previously, whilst being introduced by somebody to, obviously, the work of Alvin Lucia and Pauline Oliveros, and the lineage of the late 60s and 70s avant-garde explorations into Earth magnitude and compositions and electromagnetic energy. So that work was always simmering in the background as a legacy that was kind of very potent to anyone considering working on that scale, let's say. But it was only quite recently, after reading the Douglas Kahn text, Earth Sound, Earth Signal, which was almost astonishing that text hadn't been written 20 years previously, in fact. As a book, it outlined the lineage of artworks, contemporary music, experimental music, kind of responding to Earth energies and the electromagnetic spectrum. So it was almost, after reading Kahn's text, that it was almost a call to adventure, to try and respond to the theme of radio and the scale of working, on a global scale, let's say. In terms of Emptyset, our background prior to that had been working within a studio-based production setup that was very much exploring sine waves and noise and elemental audio signals within the context of analog media and analog hardware. Whilst producing a studio-based project, we initiated our first non-studio project, let's say, and that was a project which was called Medium, that came out through an album that was, I think, presented in 2010. And it involved us taking our studio hardware-based process and translating it to an architectural setting. It's almost taking away all the safety nets of working within a studio, within the confines of a very safe environment, and working compositionally, performatively, in response to a piece of architecture. That piece of architecture was an abandoned Gothic mansion in the countryside of Gloucestershire in England. And I think within that process, we found that by pushing sine waves, noise at kind of loud amplitudes into the house imprinted its own signature onto those very elemental signals. For us, it was quite an exciting venture to, I guess, work in an external, exteriorized way. And I think with that ticking around in the background, Signal was the logical step from working with architecture as a mode of imprinting onto an audio signal, with now moving on to working with the ionosphere. So a big leap, but quite an exciting leap. From that movement, we tried testing ourselves initially, working with amateur radio technology, which proved to be a kind of quite impossible task for us to work with our kind of existing knowledge. And we were quite lucky within that, our production arc, that we were approached by Transmediale CTM, who were working in partnership with Deutschland Radio, and we were kind of given access to all the resources of Deutschland Radio. And thankfully, through that process, Signal was allowed to materialize. So at this point, I'm just going to pass you over to James Ginsberg to take you through the presentation of the work.
Thanks, Paul. So the first thing that I wanted to do was just play a clip from just a raw recording from some of the tests we did in the process. So we'll start there. So I'll come back a bit later to what it is that you're actually hearing in that clip. Just as an introduction to the electromagnetic spectrum, there you are. So radio obviously forms one part of the electromagnetic spectrum. Within the radio spectrum, we were working with high-frequency radio, and within the context of the high-frequency radio spectrum, we initially started experimenting with one of the amateur radio bands, which is called the 40-meter band. When we initially tried to implement the idea, the first place, our first protocol was to get in touch with Dennis Harsager, who's a former CEO of NPR Radio in America and a long-time radio operator. He was a military radio operator in Vietnam. And I think he expressed his doubts, first, whether or not we'd be able to get anything, whether we'd be able to have the process work, and also whether or not we'd be able to have any kind of results that would be worth putting all the effort into the process. I think the first stumbling block we hit upon was that I think in our naivety we assumed that somehow we could emit a signal, bounce it off of the atmosphere, and then receive it somewhere in the general vicinity. But that's the equivalent of trying to record the reflection of sound off one wall while a PA is playing. So it was something that was entirely impossible. So that meant that immediately we had to look at doing the project across a reasonably vast distance to ensure that whatever we were hearing on the reception side was, in fact, reflecting off the atmosphere and not just coming, line of sight from the radio transmitter. So I think what started is something that felt poetically very much in a lineage with the previous projects that Paul described. I think what we found was we were in a situation with a technological implementation that was taking us very far away from where we'd been previously, particularly in terms of orders of complexity. As Paul mentioned, we initially started to implement the project with amateur radio technology, which basically is using 100-watt transmitters, and this aerial is about 3 meters tall. The black box in the middle is a resonator, which is full of coils, which is tuned to the particular part of the radio spectrum we were working in. And so we had this set up on the rooftop of Berghain in Berlin, and we had a radio receiver and another aerial in Bristol, where my studio is. We had moments, glimpses, where it felt like perhaps something was happening, but I think another result of our naivety was that for propagation to happen, for the transmitted signal to bounce off the atmosphere and be received in a particular place is a very fluid and unpredictable process. You can plot charts that will give you some kind of indication of during a particular season, at a particular latitude and longitude, at a particular time of day, whether or not you'll be able to make a successful transmission. But it's kind of a message in a bottle when you're using radio and in trying to successfully make long distance communication happen, which again adds another nice poetic layer to it, but it made it very difficult to make it work. I think after experimenting in this way for a while, we had just gotten to the point of putting the project on the shelf because we couldn't make enough of a satisfactory transmission test work in order to think we could do it, and certainly not do it as a performance when CTM and Deutschland Radio became involved. This is a propagation prediction chart. The facility that Deutschland Radio gave us access to is the oldest transmission station in the world, operating transmission station in the world, which is in Nauen, which is about an hour outside of Berlin. They spend most of their time communicating with battleships in the Persian Gulf because apparently ship-to-satellite communication isn't as reliable as using these the long-distance radio aerials, which was quite a surprise to me. So they took some time out of their busy schedule communicating with battleships to let us start experimenting. So I don't know if you can see, but in the top left corner, this is a propagation prediction for 6 o'clock in the afternoon to 7 o'clock. As you see, the green line around France, that is the area at which you'll have a maximum signal strength for reception. In the middle is a radio station in the center of France called Issoudun, excuse my pronunciation, which is a sister station of Nauen. The idea was that in Nauen, they were going to transmit now in the 60-meter band, which is not an amateur radio band, which meant that we could do it legally, we wouldn't have any time limitations, et cetera, et cetera. So the idea was that they were going to transmit with 100,000 watts, which is obviously quite a large incremental step from what we were using with amateur radios. They were going to receive it in Issoudun. They were going to transmit it back on another channel, and it would be received again in Nauen and then piped back to the venue in Berlin, Hau. But as you see, as you go through hour by hour, all of a sudden at 7, you've more or less lost your prime reception area, and by the time you get to 8, you're out of even the weakest signal. So that meant that there was only potentially an hour to work with to make this work, which also meant that we couldn't, for example, do the performance as part of an evening program. So in the end, we had to look at doing a performance that was going to happen in the mid-afternoon, and we had to work with the fact that there was only really going to be an hour or so of usable, workable time, which wasn't necessarily even guaranteed to work, because if there was a solar storm or something, some kind of particular a pattern of solar radiation, that there would be no possibility of propagation working. These are just a few pictures of the area around now, and each one of these aerials would be used to be matched up with a particular ship, I believe. I went to go do the initial test in Nauen, and we immediately hit another stumbling block, which was that because they're putting out 100,000 watts of electromagnetic radiation, trying to then receive a return signal in a adjacent frequency was impossible because of the amount of interference. So we turned on the system, they received it fine in France, we were picking up the return signal in an intermediate station just for testing in Holland via the internet, and we could hear the return signal, but there was absolutely nothing in Nauen. So that meant that it was going to be impossible to run the project as we had intended. This is the interior of the Nauen station. So the solution that was agreed upon was that in the south of France, they were going to pass the received signal onto a transmitter that was I think 5 or 10 miles away, and that we were going to try to receive the signal at the venue during the performance. Let's see, this is how in Berlin where we did the performance. So yeah, we ended up basically mounting an aerial on top of the theater with the help of a few local ham radio operators, and then sending the signal from where we were via ISDN link to Nauin, from Nauin bounced off the atmosphere to Isiden, retransmitted, and then picked up in How. You know, by the end of the second tests, we'd managed to get a successful transmission, albeit one that was only decent in signal strength for about a half an hour. You know, amongst this entire process, there was a compositional process. I think after we'd finished our last studio album for Rasta Noton Recur, we decided we'd have a year or so away from working on music, which was a great relief. And so we got very excited and very involved in working on this project, somehow forgetting that it was actually a music project and that there was going to have to be a phase of kind of composition. One of the kind of problems with that phase of composition was that in previous projects, we were able to work within our processes, whether it was within an electrical process, a mechanical process, or a spatial process. In the context of this process, there was more of an incremental workflow where we would create content, we would do a test, we would see what had been imprinted and what effects had happened, and then we would make another attempt at it. In the end, we came to a 40-odd minute sort of suite of music that seemed to provoke the process as, let's say, dramatically and interestingly as possible. This is a shot of the visual presentation during the performance. When the radio spectrum is visualized, it's as you see on the left and the right, you see a wide area of the spectrum, and then within that wide area of the spectrum, you can see activity around certain frequencies. So, for example, if you're tuned into 7.000, you'll see, and you have something that has a wide bandwidth, for example, music, which has bass and treble and everything in between, you'll see an amount of activity. If it's Morse code, you'll just see one sine wave kind of popping up and down. So the visual presentation of our performance was based on an implementation of software-defined radio visualizations showing the transmission and the reception, and then left and right on the big screen in the background, you can see the unimprinted sounds and the results. And I believe that's all I have to say.